All right. Are we good? Do you want me to count myself in again? Okay. All right. So today we're talking about bringing your Windows 8 and Windows Phone apps to life with push notifications using Windows Azure. Extremely long title. I didn't actually realize these were hour-long sessions until I landed in New Zealand. I thought they were hour and a quarter, but that's okay because we can still build a lot in 1 hour. So my name's Nick Harris. I'm a Windows Azure technical evangelist. Who here come to the mobile services session I did this morning? Okay, cool. So basically you saw how easy mobile services made it to send push notifications. In this session, we're going to focus on what you do if you've got to build out that backend on your own. So there are some application scenarios maybe where you need a lot more control or whatnot, and you do have to go out and build out those scenarios on your own at the moment. So this session's really about showing you how you can do that. But for those that haven't seen the mobile services session, I'd recommend that you go and watch that because you can see essentially the converse of this, how easy and fast you can do a lot more with mobile services as opposed to jumping in and building these things out yourself. So with that, we're going to review what notification options we have. We're going to do a deep dive on how to use the Windows push notification service. So the acronym for that is WNS. You'll hear me saying WNS a lot, and we'll talk about what that is. But basically, it's the medium by which we get a notification to your Windows 8 devices. We'll build out a push notification scenario for Windows 8 and Windows Phone. We'll do it all local on the machine. If we have time at the end, we'll just do a deploy into Azure. It's all pretty straightforward, the deploy process, that is. Who here has watched the Windows Azure website session? A couple people? Okay, so we'll try and slot in a deploy at the end. And then lastly, we'll discuss what Windows Azure features are available to you to help you scale out your solutions. So really, this session is about making your app alive with activity using tiles and push notifications. So that means how do we go and surface new and relevant data or activities on your start screen, be it the phone or Windows 8, such that you can draw users back into your applications. Because really, at the end of the day, what this is about getting users to engage with your application again. And that's why we have it on the start screen, and that's why we try and keep them up to date. And as it says there, alive with activity. Before we jump in too deep, we'll start with what are our notification options. So I'll talk to Windows 8 first. So every Windows Store app that you have has a basic or a static tile, and it's one of two sizes. It's either a square tile or a wide tile. Now these are defined in your package manifest when you create your first Windows 8 application. The user can control what size they want pinned. They may say, I want to pin a wide tile, or they may change that pin size to a smaller tile, or the square tile. And we'll see later today how you can target sending updates to both those sizes such that your user is always going to get that fresh content. But both of these can also have live updates. We call them live tiles. So it's essentially a way that you can push that new and updated data to your tile. So live tiles, they're basically updated using predefined templates. So what that means is we've got maybe, I think it's 30-something tile templates for sending push notifications. That bit.ly up the top there, if you want to write that down, you can actually go and see all the different template variations that we have. In actual fact, I'll click out to it. But the way these tiles are represented, let me see if I can figure out how to get onto the screen here. There we go. The way these tiles are represented is using XML. So the wide tile and the, I've just got this screen here a bit funny. So your wide tiles and your square tiles all have different template types, and you can see here that each one has its own unique defined layout. So as I'm scrolling down, you can see all the squares have gone through. Now we've got image-based ones with text, ones which we call peak image collections. So this is whereby the image peaks up and reveals some text and then pops back down. It makes it more interactive and, I guess, visible that something's moving or changing. But you can see there's a large number of template variations there. And essentially, those templates are driven by XML. And to update your screen, you need to provide that XML. and push it to your client. And we'll build out that scenario today. So as you saw, there's text only, image only, and combination of both. As far as the images are concerned, you've got JPEG, GIF, and PNG support. The max size of the image that's going to be shown on a tile needs to be less than 200K. If you define a resource that's larger than that, then it's not going to download and it's not going to show. So that's something to be aware of. And lastly, there's a number of different delivery mechanisms that you can use for delivering these tiles. There's local, scheduled, periodic, and push. And I've got a slide coming up which will show us when to choose which one for your application scenario. But for now, let's cut across and do the easiest demo I've ever done. Boom. There is the start screen, and these are live tiles. So you can see up in the top left, there's my mail client. I'm not sure what emails I'm getting, so I do apologize if there's something weird or different there. But anyhow, the everyday rewards tile there, that's on what's called a notification queue or a tile queue. So you'll see that it cycles through 5 messages, and then eventually we'll get back to the start. In the left of that tile, you can see what we call a badge. And a badge is a way of representing something that's changed in your application. So in that case, it's using the message badge, saying, I've got a new message. Oh, sorry, my mistake. That's interesting. There is a badge which is the same shape as that, but the badges are always defined over here. That's the application icon. So for the email app, my badge is what we call account badge, and that's of 17. You can see that I've got square tiles here, wide tiles, and you can see a number of those different templates around here. You can also see that this is peaking there, so that's one of the peak image collections. But that's essentially your live tiles. Now, can someone tweet to @CloudNick, and we'll see what a toast is? So that's another way that we can interact. Does anyone have a Twitter client handy? What's it, Come on, Ryan, you should know my alias. Did I? Okay, I missed it. Do it again. It should pop up in the top right when we get one. Eventually. So you sent it. We just got to wait for my Twitter client to actually know that we're getting something. There you go. It's up in the top right there. But that's Ryan. Hello, Ryan, from Microsoft New Zealand. You guys probably all know him. But that's a toast notification. So we've already looked at toast, tile, and badge notifications. So let me cut back to the deck, and we'll carry on here. And there is our notification queuing slide. So you can specify a tile is enabled for notification queuing. And when you send a push notification, basically you can specify what's called a tag. And that tag will indicate that it's got a place in the queue. If you want to update one of those 5 rotating items in the queue, you just do another push to it with the same tag, and it will replace it. And that's what notification queuing is. Let me move on here. Secondary tiles. So weather applications are a great example of secondary tiles. So an application doesn't have to have just one tile. You can go and pin multiple tiles to your desktop. And this example, Redmond, is 70 degrees. But you can also go and pin tiles for, say, different countries. And in fact, I think I've got it up on my screen here as well. You can see that I've got a tile here for Redmond, one for Gold Coast, one for Auckland there. And with those pinned tiles, essentially they're called secondary tiles, I can target different updates of the content to each of those individual tiles. So it's another way that you can have users drop that relevant information onto their desktop that they're actually interested in and not be restricted to just one tile. Moving back, toast templates. We saw one toast template that Ryan, when Ryan sent me a tweet, it had his picture on the left and then some text, but there's a number of toast templates there. Some are basically just text, some are image and text. Now, toast are a great way to, I guess, inform the user of something that's sort of important. You wouldn't use it for critical things to say, there's a, some big natural, storm or something coming and to run down into the cellar or something like that. You wouldn't use it for that because anything to do with push notifications, there's no guarantee of delivery. So you can send a push notification to WNS, And in practice, it's great, but there's no guarantee of delivery. So whilst it may be good, it'll give them forewarning, you wouldn't rely upon that as being the only means that you tell them that something bad is happening and to move or to park their car because there's a huge hailstorm coming or something like that. So that's one thing to take away with Toast. The other thing is, don't overuse Toast. If you overuse Toast, it's going to be quite, it can become quite annoying to users. So Toast will actually show up whether you're in the start screen or whether you're, say, on the native desktop editing a Word document or writing an email. That Toast is still going to turn up, and users have the option to go and turn those Toasts off if they get sort of annoyed with your application sending it too much. They may perhaps go and remove it. So use Toast wisely when they're relevant. So badges we talked a little bit about, but this is basically the only options you have for badge. You've got glyph and numeric. So glyph on the left, you can see all the different options there. You'd use the glyph of none to go and replace one of those badges when you don't want it to be shown anymore. The numeric ones, you can only indicate 1 to 99. If you go over 99, it just adds a plus on the end. Some of my email inboxes have thousands of unread messages, so that's an example of where you'd have 99 plus. This particular slide, while it's not beautiful like the rest of mine, it's really, the content is excellent. It's a great snapshot to show you when each type of delivery mechanism is appropriate for your particular application and what type of notifications are supported. So if we start on the far right, push notifications, which is what we're talking about today, support all the different notification variations: Toast, Tile, Badge, and Raw. Now, I didn't have a slide on Raw because it doesn't really show you much. I could have perhaps put a fiddler trace up, but a Raw notification is essentially a way to send a data packet to an application. Perhaps you want to go and send them an entity or an updated product list or something like that. You can use a Raw notification to do that. So it's more for sending data as opposed to images or information. Periodic notifications is another applicable one to cloud-based solutions. A periodic notification, your client application will poll a service at an interval, and it will pull down a tile and then update it locally. So in this case, your service with a periodic notification would be returning XML, and the application would grab that XML and update it. But there is a frequency that you can only get down to here, which is, I think it was 15 minutes, is the most granular frequency a periodic notification can be run on. So if it's reasonably time critical, push is better because it's, almost immediately. You can send that when the event occurs. Scheduled is great for on the local machine if you're going to go and, say, add a calendar appointment or something like that, an event that you know is happening in the future. You can schedule an update of a Toast or a Tile to display that at that point in the future. And local, basically your application has to be running to be able to go and update those. So in the event of Tweetro there, I think I opened the application, and while it was running, it may have used a local notification rather than a push notification to receive that. But I'm not too sure on their specific implementation. So let's have a quick look at Windows Phone. Windows Phone's quite a bit easier. There's a whole lot less options, but that's because it is a phone. But you can still do some very cool things, and they're quite similar to Windows 8. So you can send a Toast, and that's the Toast up the top there. You can send tile notifications. Now, the tiles that you can send to Windows Phone basically have a front side where you can control a count, which is similar to a badge on Windows 8, a background image, and a title. The tile on Windows Phone also flips, so you can have that flip and show back content. And that back content will display, again, some text, a background image, and then a title as well. So they're your options with tile notifications on Windows Phone. There's also this little guy, raw notifications. And Windows Phone also supports raw notifications. It's a great way to notify your app of perhaps some change data, or to implement a commanding pattern whereby you tell your application that it has to call into a service to do something. So Toast, Tile, and Raw, but the Tile here, in this case, also supports Badge. So that's an important thing that I should distinguish. With Windows 8, when you send a badge notification, that's its own unique payload. You send a badge on its own. It's not composed with a tile. With Windows Phone, the count here and that's packaged as part of the payload for a tile. So you can't send the count independently of a tile notification in Windows Phone. So let's look at the lifecycle of a push notification, and basically what we'll do is at each major step we'll jump into Visual Studio and start coding that scenario. So the first thing here is, in this overview, is an architecture diagram, pretty much bird's eye view, but the thing I'd like to point out is the things in green, they're basically platform components that Microsoft provides to you, and you go and actually build everything in blue. So blue is where you have to write code, and that's where we'll write code today. Green is a service provided for us for free, and we just consume it as part of our application. So we really only need to know how to interface with these things in green. So the first thing in a push notification scenario is you need to request a channel URI. Now that channel URI uniquely identifies that tile for that application. So if you've got secondary tiles, you'd have a main app URI and then a URI for each of those secondary tiles. Essentially what it means is it gives you a unique addressable URI to post your notification to, which means that that particular tile will be updated. So you could address your main app tile, or you could address your secondary tile using the URI. The next thing that we need to do is actually register this URI with our cloud service. So in this case, what we do is we take that URI and we push it up to our cloud service and we store it there. This is where you implement your business-specific logic for your application scenario. That determines, hey, it's now time that I need to go and send that notification. If we used a weather service, perhaps it would be there's a hailstorm warning and you've detected that with some worker role that's determining what's happening with the weather. You'd then pull all the channel URIs for, say, the Auckland weather, and then you'd push to all of those channel URIs the latest update. So to push it, we need to do a two-step process here. And the first thing we need to do, and I'll call out the differences with the Windows Phone scenario after we talk through this Windows 8 piece, but with Windows 8, we're pushing through what's called the Windows Push Notification Service. To push to this, you need to authenticate first, and then you need to compose that notification payload and then post to that channel URI to eventually have that notification delivered to the notification client platform, and then that tile, toast, or badge or whatnot will surface on that start screen for the users. So the one thing that's different here for Windows Phone is essentially this component. For Windows Phone, we call it the Microsoft Push Notification Service. They're two separate entities, and they both have two separate APIs when we talk about step 3. So with Windows Phone, there's the option to be able to push a notification without being authenticated. We'll see that today. So let's talk about step 1. Our Metro app in this case, or Windows Phone app, calling into the appropriate API. In a Windows Store app, it is the WinRT API. So we call into that and we get a channel URI. And the basic guidance we give to people is to request that channel URI each time the application runs. The reason that we do that is because channel URIs can change, and we want to make sure that your application doesn't have an expired channel URI in its cloud service. So expiry for a channel URI on Windows 8 is every 30 days. Sometimes if, say, WNS needs to purge a whole lot of the data that it just stores in memory, it may have to purge those URIs, in which case it's always, again, why it's recommended to request a new channel URI each time your app runs. It's not an expensive operation at all as far as, overhead of making that call. Everything with WNS is free, so don't think there's a charge associated with that. The actual channel URI is created by WNS. So what's happening under the hood there is the notification client platform calls into WNS and gets that channel URI and returns it to the app. And lastly, the channel URI can be opaque to the application. You don't need to know what the query string is on the end of it. You just need to know that it represents a tile, be it your main app or a secondary tile. So time to get away from the slides and into the stuff that I like, and hopefully you guys do as well. We're going to start building some of this. So let's start with a Windows Store app. Just do a blank one. We'll call it notification demo. How's the size of that font up the back there? It's good? Okay. Excuse me. Okay. So I've got my client application here. So if you remember, that first step that we talked about was called the request. So that's what we're going to do. Later, we'll register the channel. But we'll deal with that when we get there. So to request a channel on Windows 8 is quite straightforward. We're going to make an async call. So I'll just flag the method as such. And then what we can say is var channel is equal to the push notification. Whoa, what did I do there? The key combo I didn't know existed. Awesome. All right. Yeah, Windows something. I think it was Windows dot. Yeah, cool. There you go. That's how you do split screen. But this API here essentially returns you a channel. And that's that first step that we talked about. So create a push notification channel for application async. There is an overload here, or a different method, I should say. Let me just clean this up here. You can see that you can create a secondary tile as well, like that as well. But let's do this, because we're just going to deal with the one case today, because there's a lot of code. So that's our channel. Let's look at Windows Phone. So for Windows Phone, I'm going to use a pre-built solution that I built out. So to request a channel in Windows Phone, use the HTTP notification channel class. There are differences in these APIs. The first thing you do is you basically search to see if that channel has already been registered and open. If it hasn't, you need to specify a handler that essentially will execute when you do receive a channel URI back, and you call open. So we'll go and look at this once we move back, but there's a few extra lines of code here to do in the Windows Phone case versus the Windows 8 case. But both, in essence, get back that channel URI that you can use to identify your tile. So let's look at step 2. So step 2, we need to register that channel with our cloud service. So in this case, really, when you build your cloud service, you should have you should be exposing the endpoint that you register these with over HTTPS. Shouldn't be using HTTP in case anyone wants to sort of go and find out what those channel URIs you're posting up are. And you should really have an authenticated cloud service such that not anyone can just start spamming data into it. Today we'll just go with the most basic case, otherwise we'll be here till late tonight. So we'll just do an unauthenticated service. Once you receive your channel, you need to store it somewhere, right? So in Windows Azure, we've got table storage, which is non-relational structured storage. It's a little bit similar to NoSQL. And we've also got what we call now SQL database. You may have heard it called SQL Azure before. In this case, I'm just going to use on local SQL Express, which means that I can basically publish that later up to SQL Azure when I come to that step. Then the last thing we need to do in this is create business-specific logic to send our notification, which is really part of step 3. So let's write the code to register our cloud service. So, excuse me. To do this, we really need a reasonable amount of code. So for those of you who watched the mobile services session this morning, really contrast what mobile services is giving you as opposed to all the steps we have to go through now. So we're going to create an MVC application called Register Service. It's going to be using Web API. And that'll create in a second. And for me, even though you request a channel, then you register it with your service, I like to implement the service first and then do the call in from the client application. So that's what we'll do here now. So let's define our entity that we're going to save that represents a channel. So I'm going to call this guy channel, drop that in, and don't worry, I have come prepared with all this code to use snippets. So there's my channel. It's got a unique ID, it's got a URI, which is our channel URI, it's got an expiry that's optional because we know Windows Phone doesn't have channel expiry as such, whereas Windows 8 does. And we've got a little flag to say whether this channel is Windows 8 or Windows Phone. So the next thing I'm going to do is add a class that uses EF code first to go and generate the DB. And I'll call this guy, what will I call this? I just want to make sure it's going to be the right name for the rest of my snippets. I've just had a mind blank. DB context. I think I called it push DB context. But essentially, this is a class that's going to allow us to go and interact with the database. So let me do this. PN push DB context, there it is. So quite a simple class. We're inheriting from DB context, so we can do things like add and save changes to the DB. We're using DB set to indicate that we've got a channel table storing entities of type channel. And that's basically it for our data tier. This will then generate the appropriate SQL DB and tables for me based on this entity definition. So that's EF code first, and it's pretty cool in my opinion. So I didn't really have to go to the SQL layer. So the next thing that I need to do, now that I've got my sort of entities for my data tier defined, is I need to create that service API that's essentially going to expose that registration endpoint for me. And I'm going to call this a channel controller. I'm going to use entity framework read write actions. I need to build this guy first. Okay, it's built now. Channel. Now this is sort of cool in that we can go and generate a full, REST-based service tier using just this nice little form. So essentially we said we're expecting channel entities and we're going to use the push DB context to go and interact with the DB. And you can see on the screen here now I've got an instance of push DB context, and really what we're going to work with today is mostly the post channel. So that's how we insert or push a new channel up to this up to this web API. So the web API would expect API/channel, and within the body of that particular post request would be the channel, which gets deserialized into here. We then add the channel to the channel table and call save changes. On the response that goes back to the client, I want to send back the ID so I can track what my channel ID is for that particular tile. So that's my service tier done. So now let's look at the client code to call into that. And this is where it gets a whole lot more fun. Who's seen a lot of code already? Is this okay? Level 300, there'll be a lot more. But yeah, really, when I attended TechEd, what I wanted to see was more code samples and less slides. So I'll try and deliver on that to you today. So the next thing that we're doing here is actually registering that channel with that service we just implemented now. So to do that, I should have this snippet. So you'll notice that it's trying to use a channel object here. So what I like to do is I like to really serialize everything between my client and service using JSON. And there's a class called the data contract JSON serializer that you can use to do that. But what I really want is my service tier and my client tier to use the same channel class, such that if I change it in one place, it actually reflects that change in the other. Now you may go and do this with, say, portable class library, or separate it out into another assembly, then build it for both. For the purposes of this demo, I'm just going to add it as a link. So it's a cool feature in Visual Studio. You can do add as link, and now it's just linked that file. So now I can control .that, and you'll see that it's pulling up that channel there. Now the next thing that I'm doing here is I'm using the... Did someone say something? Okay. Right, so the channel, as this is executing every time the application launches, I really want to see what we've got is this local settings a bag here that you can essentially store data in that will persist across application runs. So what I'm doing here is checking if I've already got that channel registered, because later as we move down, we'll be performing a post to do an insert, but if we've already got a channel, we'll be doing a put such that we update. So this is our channel DTO that we're going to serialize across and up to the cloud. So the next thing that we do is we need to actually get that channel and serialize it into the payload of a post message. So let me resolve some references here. The first thing that I do is I get a reference to the data contract JSON serializer. I tell it I want to serialize a channel. The next thing that I do is I go and write that channel object here. That's got the channel URI that we talked about that we received back and the channel expiry. And we go and serialize that into our serializer. We rewind the memory stream back to 0. And this is some code that I'll just add for debugging purposes. So we can remove that. So now we've got a serializer that has that entity within it serialized, and we basically got to go and drop that memory stream now into a stream content object, which can be used by the HTTP client. So the HTTP client is basically a wrapper around a HTTP web request that provides really neat and nice methods for performing operations against REST APIs. So if I said client.put, you can see there's a put operation, there's a post operation, and there's, say, delete, get. So it makes it really nice to do. You don't have to go and set the HTTP method and those sorts of things as you'd have to do with a web request. So the next thing we do is specify that we're pushing JSON up. And then the last thing that we need to write is the actual execution of that, where we define whether we're doing an insert or an update of an existing item, and then call post or push appropriately. So let's do that. And let's say insert or update. Right. It's always hard to get the snippet. I think that's right now. There we go. Indentation right. Okay, so now this, the first thing we need to do is we need to specify where that controller that we defined before, if you recall, we called it channel controller. So by convention, to do a post to this, we go hit API/channel. Now, when I spin this guy up, it's going to go and host it in Visual Studio on a port 8268. So let's close that. So we need to make sure that we are hitting the right one. So that's our URI where we have to perform a post to do an insert. So here again, I'm checking, have we actually registered this channel previously? In this case, it's no. So we come into here and we call client post async. We provide the channel that we're performing the post to, and we provide the stream content that had our serialized item in it earlier. So that's basically it. That will then serialize that channel class into the payload of a post request and hit our service with it. If we get a response, I go and grab the channel ID from the content of the response. And that's basically all I have to do there as well. So if you recall, one of the small changes I made when I generated this guy was to specify to return back the channel ID in the response when a post has been executed successfully. So that's my client application for Win8. Should we spin it up, or do you want to see the WinPhone code to post to the same service first? Any preference? Spin it up and get some action. All right. So let's spin up our service first. So I'll set some breakpoints. Let's pull this across. Controllers. Okay, come down. Channel controller. Post channel, we'll put a breakpoint there because that's what we're going to hit. And then in our client application, we'll drop a breakpoint in. Basically, we'll put it here once we receive the channel. Now let's spin up our client. Now our client isn't really doing much at the moment. Let me just fix this. Okay, I got to stop that. So because I added this as a link to the channel class in the web project, it sort of dropped in that default web namespace, which it doesn't really use. So let's spin that up again. Now let's spin up our client. So our client doesn't really have much in it apart from some code that returns a channel. So if I expand this, you can see there's my channel URI. It's got a token, and we don't need to really know what that means. We just know that's how we can target the start screen of that app. The next thing that we need is the expiration time, and that's more so you can build smarter services or backends to not post to expired channels. So the next thing we do is we go and serialize that content. And then this is where we now step in. We step in, step further. Now we're performing the post, and you can see, boom, it's jumped over into my service tier. Now this one's going to be a little bit slower because it's gone and generated the DB. It was nice and fast today, actually. And now I'm returning my response. And that would have just then continued through the client app. So let's have a look that we actually got something in a database somewhere that we never actually created, and see that EF has gone and generated that for us. So let's refresh this guy. Register service. I used the same, so there's something to keep note of. I used the same service name as I did in my dry run, so essentially it's using the same DB. So we're going to see a few channels here probably, because it's just reusing the same thing. So you can see there's my demo before. The latest one is obviously number 6, but let's just say delete from this, so we can start with some clean data. And let's just run this guy again. F5. Okay, it should be hitting our service sometime soon. And I know what's happening actually. It's tried to hit the put request because it thinks the channel's already registered, although it's not there. So let me, we'll come back to that. It's all right, we'll overwrite that. But essentially, know that we can store that channel URI there. When I make some changes to the package app.x manifest later on, it's going to go and clear that out. Actually, to make sure that happens, I'm just going to uninstall this guy. So we clear that state that we had there. Okay, so that's step 2. On Windows Phone, it's much the same. It's just not as nice as far as the async is concerned. So we can hit this. So we've got our channel URI. We need to make sure it's the same as same endpoint that we were hitting before. There we go. So what happens is when we get our URI back, this event handler gets called. To be able to receive tile and toast notifications, we need to call bind to shell tile or toast. I'm not sure why it's not really automatic, but that's just the way it is. We don't have a nice HTTP client in Windows Phone, so we're using HTTP web request specifying to do a post. Now to write the stream, we need to use these methods, and they don't support the async and await syntax. So you can see that it's there's a lot more there to sort of get your head around as far as tracing through the program. So what we do is we get a stream, and that provides us a stream that we can serialize that entity to. Same thing again here. Data contract serializer, we take that stream, we specify it's not Win8, there's no expiry, and then we begin to get response, and that's going to post it to our server. So let me debug, disable all breakpoints, spin that guy up, and we'll come back to that later. So as you can see already, there's quite a bit of work to getting a push notification workflow going end to end, and quite a few concepts to understand. But hopefully this session will get you across it, and you'll be able to send push notifications basically by reproducing these steps. I'll make the sample code available somewhere, maybe my blog or something. But the next step that we need to do now that we've got those channels up in our cloud service is to authenticate against WNS in this case, and then push a notification payload to WNS targeting that channel URI that we got from the client. And that basically says, send this notification to the tile on this person's machine. That's what that channel URI is. It's a unique identifier of that tile for that application. So we need to authenticate and push, and then eventually WNS, it's normally pretty fast, will go and deliver that message to the client, and we'll see the notification. Now to do this, there's quite a few steps, so I think we'll walk through them in Visual Studio rather than in the deck. So let's cut back. So the first thing we need to do in this third step is to request those credentials. So if we go and say to manage.dev.live.com/build, and we provide a password here, we can come in and we can request credentials for our application. Okay, that is a toast message. Other spaz, interesting, interesting alias. But so what we need to do now is we need to provide a couple of values to our form here, and these are going to give us our WNS credentials. So we need to grab those values from our application. So in the package Apex manifest, we go to packaging, and the first thing we need is the package display name. So I come and drop that in there. The next thing I need is the publisher. So I get that and put it in here. Now, a key thing to take away is if you have a different publisher name than this, you're going to get an basically unauthorized response from WNS. It needs to match up because it's that plus the credentials that it uses for this scenario to work end to end. So if you're getting a 403, go and check that you provided that properly to that wizard, and then perhaps reset your credentials like I'm doing here. So the first credential that it gives you is, let me zoom in here, is a package name. Now this goes in the client app. The next two, I need to remove that space. The next two go into your service tier, and they're used to auth against WNS when you go to do a push. So let's save this guy and make two small changes here. The other thing, which I probably should have done at the very start, but if you want to receive a toast notification in your client app, you need to define that you're expecting toast or your app is toast capable. So that's important. The next thing is if you want wide tiles, you need to actually go and specify a default wide tile logo for the application. That's that basic tile that we had on the second or third slide, and that's where your app starts out and then can be updated later. If you don't define it, you can only send square tiles. So now what we need is just a little test stub to start really just sending these push notifications. So I'm going to call this push controller, and I'm just going to use an empty with read-write actions. So if I come here, I'll get rid of this stuff, and we'll just use a simple get method. And now we'll just drop in some code to send a push notification. So the first thing that we do here is, the way I want this to work is I want to hit API whack push, and this is simulating, my business logic specific scenario. Obviously, you may have some kind of worker role that's watching, perhaps a National Weather Bureau or something like that to determine when something occurs. I'm just going to invoke that functionality using a simple API here. And I'm going to pass in the ID of the channel I want to post a notification to. So I'm going to use a reference to my DB context. I'm going to say, in that DB context, find the first channel that matches the channel ID passed in. If the channel is Windows 8, then we're going to send a notification. Now, we've got this Toast Content Factory. Now, this isn't a package that comes like built into the .NET framework or anything like that. It's a NuGet package. So for those who haven't used NuGet, NuGet is essentially a way to drop reusable components or codes, assemblies and such, into your solution that you can go and use. And this is one that I've authored along with some other members of our team over the past year or so, and it's actually reasonable as far as making it quite easy to perform that authenticate and push portion of WNS. Otherwise, you'd be dealing with HTTP web requests, OAuth 2, and serializing XML payloads for notifications. So that error, basically I targeted that package at my client app rather than my server app. So you can see now it's gone and dropped that in, and I've dropped in some documentation here that tells you how you can go out and use it. That's what we're going to do now. So let me resolve that. So if you recall, the first step was to authenticate, then push. So we'll say private, and we'll call this an iAccess token provider. Resolve that. New WNS access token provider. And now this takes those other two credentials from the portal. So let's jump back here. So there's our package SID, which is our first parameter. Now we need our client secret, which is our second parameter. And now that will deal with our auth. So you can see now what we can do to create a notification. It's just a matter of saying, create toast image text 01, 2, 3, 4. They're all those different templates which we saw on the website. So if I want to create toast image text01, I need to specify that to get my toast. I need to specify some text, say hello New Zealand, and then I need to specify an image. So prior to coming to the session, I went and uploaded some images to blob storage, and we'll just put in a special one I prepared for today. 150. And that will be our toast notification. It'll include some text and an image, and then we basically call send, target the channel URI that we originally received from the client, and push that toast notification provider in. And that's it. So this is WinPhone, so I'll comment this out. Just drop that there, and let's get a toast going on Win8. So build this guy. Let's start our service tier. Debug, disable all breakpoints. Let's put a breakpoint here so we can see we're hitting it. So we'll spin up our service again. And then we'll spin up our client. So there's our client. And now we'll just double check our DB. Make sure we got that back. So there's our Win8 token now, or channel URI, and it's ID8. So now I can invoke that method using API/push 8. So here we go. We found a channel. It's our Win8 channel, composing a toast, and fingers crossed for me, please. A lot of code. Come on. Boom. There you go. And there's my MS Paintbrush Kiwi in the left there. That's really the best I could do with paint and my extremely limited artistic skills. So let's have a quick look at tile. So I'll just stop this. So I've got a tile here available as well. So the tile code is essentially quite much the same. But in this case, remember how we talked about a user can come in and they can say, well, let's, it's not true on secondary tiles. Let's hold that one. What's going on? I've got control pressed. There we go. See how I can come and hit smaller on this? From a programming perspective, you don't know whether that tile is small or wide. So when you send a notification update, this is our tile. Let me move it here so we can see it when it comes in. When we send a notification update, we really have to send both a wide and a square tile such that either way the user's got the app pinned, you're getting some updated content. So in this case, I'm using the tile content factory, creating a wide peak image text. It's got an image associated with it, some text for the peak, and we're also creating a square tile. And in this case, it's just an image, and we're setting the square tile on our original and calling send. So let's run that one and see our tile update. All right. So again, push slash, sorry, API slash push slash 8. So we click down through. That would have been our toast. And again, now we've hit send on the tile. So hopefully, boom, there it is. I swear I do not know that girl. To my girlfriend, if she's watching. But she's all over my desktop. No, seriously, I found her on the internet. It was just on the MSDN documentation. And we were there before. Probably sounds bad, but yeah. That's just one of the sample tiles. But you can see there that that was pushing and peaking. We can see the text. It's going up and down. What I did forget to show you is if I hit smaller, boom, there's that square tile. So if that was pinned as small, I would have seen the small. And if it was large, I would have seen the large tile. And at the end of the day, the user, irrespective of how it's pinned, gets that active content. Badge is much the same again. But we'll probably, do you guys want to see Windows Phone or Badge? Badge? Okay. Okie dokie, let me stop this. So badge, sort of my favorite badge is really the it's the glyph badges, and they're, if you recall at the start, the ones that really just showed a picture as opposed to just an account. And my favorite badge is the new message badge. I don't know why, it just looks good. But if we say var result there, we can go and send a badge. Spin this guy up. And we'll see what that looks like as well. And then I want to talk a little bit about the result you get back from WNS and MPNS, because it's extremely important when you're building out a scalable service to actually look at what information is being returned to you. And we'll say 8. So we've hit it. There you go. You can see the little mail badge has just popped up in the screen there. So that's pretty cool. This X is an app icon that I didn't specify in my package AppX manifest, but you can specify to not have that included, and then it will look more like this without a logo. So that's badge. Now, if you recall, I said you do get some information back from WNS. So WNS can send you back information about the status of that device, plus the status of whether WNS received the notification or dropped it or whatnot. So you can see device connection status here says not applicable. Essentially, when you call send, I've got another overload here that takes options, and you can say request for status. That will tell you things like the device is temporarily disconnected, or the device is disconnected. If you're trying to send millions of notifications, you really want to take that information when you get it, drop that into your data store wherever it is, such that you know that the last time you send a notification to this device, it was disconnected. From that, for instance, you may perform some kind of exponential backoff, such that you're not trying to send notifications so frequently to that device until its status finally turns up again as connected. So that's really important, because it means you can start reducing the size of that data set that you're trying to send a push to. So that's it for the badge notifications, all on Win 8. Windows Phone, much the same, similar kind of code base. I think you guys will understand how that works from there. So I think we should probably get back to the deck. We've got only a few minutes left, and really I want to show you one important thing around building out these solutions on Azure. So let me cut this across. So the key thing, that solution which we built there, we can deploy that to Azure. Now, we provided only a very simple test harness to send those notifications, but you need to understand that when you start considering the client base you can have for Windows 8, you really need to build your application such that it's going to scale. And in the push notification case, if you're talking about sending push notifications to 10,000, 100,000, a million users, and you want that to be reasonably timely, which is why you would have chosen to use push to start with, you really need to have those resources available to scale out that service tier or your worker tier that goes out and sends these notifications to ensure that those updates, you don't want to be the millionth person being notified of something, right? Because if you just were doing that sequentially on one server, that's going to take a very long time for you to finally get that notification. It's better to parallelize your work and have it spread out across multiple, say, worker roles or services. So to put that in context for you, this is some data that I got from my friends on the WNS team. And this is just for the communications apps on Windows 8, which is your Mail app and your People Hub. So that's something that everyone has. They're Microsoft apps, which we've written. And you can see here that per day, if we look at the far right, they're sending over 7 million notifications a day. So that's a lot of notifications to deliver. And their backend services utilize Windows Azure to send notifications to WNS. So if we want to summarize some of the core services that Windows Azure provides, we've got on the left Windows Azure Mobile Services, which is really a much easier way for you to implement these scenarios. Watch the session that was recorded earlier this morning if you want to see that. But in some cases, you may need to go out and build services yourself. And that's what today's session was about, showing you how you can deliver those notifications in a service that you're building out on your own. Windows Azure Compute, there's a number of different places you can deploy your web tier to for registering that channel. You could use Windows Azure Websites. There was a session on that today. You could use a web role. You could use a worker role, for instance. It's similar to a Windows service. A worker role allows you to perform periodic work that it has like a well-defined on-start, on-run, and on-stop. And that's sort of the thing that you'd be using to sort of go in and poll out to these other external services that may have the information, like in the case of the weather, information that you want to send notifications about. Storage, there is table storage. If you want to use table storage to go and store your channels, that's available, as well as SQL DB is available on there as well. To help scale, we've got a CDN. So if you're sending images, for instance, in your notifications to people all around the world, you could consider putting that content on the CDN. So we've got over 26 edge nodes worldwide. So rather than someone's application having to go out and hit, say, North US to get an image out of the storage account, it could be pushed to the edge node in, say, Sydney on the CDN. We've got Traffic Manager. If you've got multiple deployments across multiple regions, essentially you can set it up to route traffic to the closest deployment based on performance. So if you're pushing your channel up and into, say, if you're pushing your channel into that registration service, you don't want to be, again, going from New Zealand all the way to North America. The Traffic Manager there would probably route you to Southeast Asia. The one key thing for these large-scale notification scenarios is caching. So keeping all those channels in cache, in memory, is a lot faster than having to perform reads from disk, whether it's storage or whether it's a SQL DB. Dropping this stuff into a cache is the way to do it. And we've got the Windows Azure Cache as an existing service, but we've also got the Windows Azure Caching Preview. I encourage you to check out the Caching Preview. So let me pull this along here. And let's finish up. So in summary, there's 3 easy steps to implement your own push notification scenario. Request a channel, register it with your cloud service where it's stored, and then later authenticate and push. Windows Azure Mobile Services makes this an extremely easy process. This morning I built out a service that did push. It was locked down using Windows Live, and it also had a whole bunch of CRUD operations for going and storing other data which I wanted to store. And that was in 1 hour. As opposed to this, we've spent 1 hour and just got notifications end-to-end working. So there's a lot of sort of speed improvements as far as implementing these scenarios. If you're building your own, the WNS recipe and MPNS recipe NuGets help for Win8 and WinPhone. And lastly, Azure will provide those resources to scale as your app grows. A whole bunch of links there. I'll make sure they're available in the slides when they're posted. And with that, thank you, and please fill out the feedback. So we have 2 minutes if people have questions, and I'll be available.